Hey, Dr. Clark coming back at you with a differential equations check your understanding video. We're in section 4.1 this time, and section 4.1 is all about solving non-homogeneous linear differential equations like looks like this one right here. And they're basically giving us the solution to the differential equation, and they have a couple questions. So first, verify the solution they gave us solves the differential equation. Identify the homogeneous part and the particular part of that solution, and then solve this initial value problem with initial conditions. And we have initial position and initial velocity, which should make sense because it's a second order differential equation, so we should have two initial conditions there. So let's start with part A here. Verify that y of t solves the differential equations. Well, y of t is constant plus constant e to the 2t plus 3t. Let's find the first derivative of that solution. The derivative of constant is 0. The derivative of e to the 2t will be 2e to the 2t. And the derivative of 3t will be 3. And the second derivative will be, 4c2e to the 2t. The derivative of 3 is 0 again. Okay, and so if I take my differential equation, which is y double prime minus 2y prime equals -6, that is what should happen. So y double prime is 4c2e to the 2t minus 2 times y prime. Y prime is 2c2e to the 2t plus 3. And that should equal -6 if the differential equation works out. And I believe that is the case because this will cancel with that. 4 minus 4 is 0. And then -2 times 3 is -6. And -6 is equal to -6. So yes, it is a solution. So this here is a solution. So that's been verified. Part B, identify the homogeneous part and the particular part. Well, the homogeneous part of the solution is the part with these constants in it. And the particular solution, so this should solve, this is going to solve the homogeneous differential equation y prime minus 2y, y double prime minus 2y prime equals 0, right? That's solving the homogeneous portion. I think you can probably see that if you think about constant. The second derivative of constant is 0. The first derivative of constant is 0. 0 minus 0 equals 0. And if you take this here, you're going to, when you take the second derivative, you'll get a 4. When you take the first derivative, you'll get a -4. 4 minus 4 is 0. So you can see that that's solving that homogeneous equation. And the particular solution is this 3t. And you can see, if you think about that, that should be solving the full non-homogeneous differential equation. And I think you can probably see that if you take the second derivative of 3t, you'll get 0. If you take the first derivative, you'll get 3. So you'll get -6 equals -6. That'll solve the non-homogeneous differential equation. So we've identified the homogeneous, we've identified the particular solution, and so now it's just, part C, which is to find the solution to the initial value problem with y of 0 equals 5, and y prime of 0 equals 7. So we're going to take our solution, which is y of t. You know what? I think just for simplicity, I'm just going to copy this because we've already done the work up here. No use rewriting it down. And if I plug in 0, I'm going to get what am I going to get? C1 plus C2 plus 0. if I plug in 0 for y prime, I'm going to get what? 2c2 plus 3. And this is supposed to equal 5, and this is supposed to equal 7. So I think if I look at this equation, I can see that C2 is probably supposed to be 2, because 2 times 2 plus 3 is 7. And if C2 is 2, then C1 has to be 3, because 3 plus 2 equals 5. So C1 equals 3, C2 equals 2. So my solution to the initial value problem is y of t equals C1, which is 3, plus C2, which is 2, times e to the 2t, plus the function 3t. And that solves the differential equation and satisfies those initial conditions right there. And that is how to do that problem. So reflection comments over here. How well did you do? Was things making sense? And then, give yourself a score. And if you're getting a 4, that's great. And if you're doing less than that, then maybe you want to do a little extra practice to lock in those ideas. All right, we'll see you next time.